This video will showcase interoperability using various routing engines accessed through Skymantics web processing service and client application. The client is a map interface that lets the user calculate a route using a variety of data sources and compare their results. Let's start by creating a route from the Washington Monument to the Washington National Cathedral. We can do this by utilizing the marker tool. First, we place our start point, and then our end point. Now, in the submission form, we can first name our route. You can choose the Routes API or WPS API. Let's go with the Routes API. Our client offers 3 routing engine options: Skymantics, Achere, and Here. Let's use Achere. There are 4 options for web processing service. Let's use Skymantics. You can choose from different datasets: OSM, NSG, and Here. We'll use OSM. There are 6 different algorithms depending on the engine. Let's choose A* and select the shortest route. You can also specify parameters for weight and height. The async option provides the route as a link. The client submits JSON to the selected WPS according to the Open Routing model. A route is returned containing a JSON feature collection, which is then displayed on the map here in black. The client can display multiple routes in the same session. Let's create a route from the National Zoo to the Washington Convention Center. We'll change the name and use the Skymantics routing engine, the NSG dataset, and change the algorithm to the A* contraction hierarchy. You can see the returned route in gold. The client also has the ability to download routes. You can see here when we return a route from the WPS, we are prompted to download the returned GeoJSON feature collection. This GeoJSON can be used with a number of clients, as you can see here in geojson.io. Now let's look at 3 examples that showcase different routing options. In this first example, we will generate the fastest route from a park to a hospital using all 3 available datasets. The 3 routes look different and have different estimated durations. This is because the datasets encode speed limits differently, and the routing engine selects the fastest streets provided by each dataset. In the second example, we will look at restricted maneuvers, a feature included in Here data but not in OSM or NSG. Here data results in a good route, while OSM results in a route containing a left turn onto Constitution Avenue, which is not possible. In the third example, we will compare routes using different algorithms, in particular, contraction hierarchies. This algorithm prioritizes the use of streets based on hierarchy, in other words, freeways versus residential streets. This can result in a faster route calculation, but not necessarily the most optimal. Using the Here dataset, the algorithm was 10 times faster, but with a non-optimal route. The road hierarchies are encoded differently within each dataset, so the results may vary. Using OSM, contraction hierarchies was 20 times faster, but this time it produced an optimal route. In summary, we conclude that different datasets and different routing algorithms can produce substantially different routes, but using the Open Routing model and WPS, we can access the data interoperably for better decision making.